Hello everyone, let's talk today a little bit about general motion. And we're going to talk about rotations, translations, and mixtures of them all. So let's see what we've talked about so far. We've talked about translation already. Real good example of translation is the motion of a cart. It moves from left to right or just along some position. Doesn't have to be one-dimensional. If it is one-dimensional, we refer to it as rectilinear. But if it's two or three-dimensional, then we're going to talk about it as curvilinear. But what we're looking at here is strictly motion in the x, y, and or z direction. So curvilinear motion might be a ball, this ball in the inclined plane. Now actually, as it comes down the inclined plane, that's rectilinear motion. It's one-dimensional. Granted, it's the dimension, the single dimension is along this line, which if you think of x and y as left, right, up, and down, that's two-dimensional. But if we just look at x along this line, that's one-dimensional. So that part is rectilinear, but once it hits this hoop, then it becomes curvilinear, right? So I can set it up here. This might be off the screen, but goes around the hoop, right? And so that becomes curvilinear motion, right? Any kind of motion that's in two or three dimensions can be considered curvilinear. So just as if I toss the ball from one hand to the other, that's curvilinear motion, right? Lots of different possibilities there. All right. So what else do we have? Then we have rotation about a fixed axis, and we've looked at this already a little bit, but the platter here rotates about a fixed axis through the center of the platter. So think of that like a merry-go-round. That's rotation about a fixed axis. Kind of consider that one-dimensional. Yeah, it's in two dimensions, but if we think of the angle as the measurement of displacement, we'll talk about that in more detail later. We've already talked about it a little bit, but we'll revisit that. Then it's kind of one-dimensional motion, just the angular displacement, the angular velocity, right? So that's rotation about a fixed axis. Then general planar motion. Planar means that everything that's moving moves in the same plane. So that might be on the page that you're looking at. But a real good example of planar motion might be this motion of a disk, right? All of the points on the face of this disk are in a single plane, and they're all moving together. Some of them are moving faster than others because of their distance from that center. But you'll notice, even though it's rolling, there's not a fixed axis that it's rolling upon, right? This axis through the center of the disk is also moving across the tabletop. This hoop does the same thing. It's going to roll, but all of the points on the hoop are in a plane, right? Let's not worry about the dimension in this way, but all of them on this ring here are in a plane, and they're all moving. And the axis of rotation is also translating, so it's a combination of the two. Okay, so those are really good examples of general planar motion. Then we have motion about a fixed axis or about a fixed point, and so I might consider pendulum. The fixed point, bring this back down, the fixed point is up here where the string is attached, and I'm sure that's off camera, but as I look at the motion of the pendulum bob as it swings back and forth, this is motion about that fixed point up there. Even if I rotate it like this, so it's kind of like on a conical surface, right? That's still motion about a fixed point. All right, so that's a different kind of motion. We'll look at that a little bit as well. All right, and then finally we have general planar motion. And general motion, not planar motion, general motion. And that's going to be a combination of the rotation about the fixed axis or fixed point, and translation and rotation. It's a combination of a lot of different things. And this gyroscope is a pretty decent example of that. It's going to be hard for me to get this going as fast as I would like to, but let's give it a shot. It's a pretty nice gyroscope. I think it's older than I am, which is saying quite a bit. All right. let's take a look. So I'm going to pull the string and get this thing rotating. Okay, and then I'll give it a little bit of motion like that. I wish it wasn't shaking, but there it is. But as this thing rotates about its axis, you'll also see this axis is moving. And I don't think it's strong enough to stand up on its own. No, it's not rotating fast enough to do that. But there's combinations. As this is rotating, you can see that motion like this. I can really complicate it and move it in this direction. But there's a lot of different stuff going on as this thing rotates. So it's not in a plane, it's not about a fixed point, it's not about a fixed axis. This is the closest axis to fixed, but this axis is not, because it's moving as this thing precesses around like this. I'm exaggerating the motion time-wise, but as this thing rotates, the axis of rotation is moving. And then of course I could move that through space as well. This might be a gyroscope on an aircraft or something like that. So it would be moving through space. Very complicated motion in that scenario. We're not going to talk about that. You might talk about that in another class, but we're not going to do that. We're going to avoid that one in this class because it gets pretty complicated. All right, but that's our general motions. And so we're going to be studying these, except for the general motion, we're going to study these over the next couple of videos. All right, if you have any questions, be sure to put them in the comments. Thank you so much.